Assalamualaikum and good day to my panel. My name is Nur Shafinas binti Mat Zurami. So today, I will present about my final year project. The title is Effect of the Kenaf core as a partial sand replacement in brick using air curing. So basically, this is my outline for my presentation today. Start with research background, problem statement, objective, scope of study, significance of study, literature review, methodology, result and discussion, lastly, conclusion and recommendation. So, the project background for my research is brick is a building materials to construct wall, pavement and other elements in masonry construction. Cement and brick commonly used in low and medium cost housing and other commercial because it is easy to produce and cheap. Sand is the main materials to all construction projects and the largest sand consumers. But nowadays, the demand of sand has increased and it brings to sand mining activities. Because of that problem, I tried to use the other materials to replace the sand. And the material that I use is Kenaf core. Kenaf core, known as hibiscus cannabinus, is categorized as a natural material. Kenaf has been used as a corded crops to produce twines, rope and silk clothes. Kenaf also has a good mechanical properties and can grow quickly. The problem statement for my research is the demand of sand has increased in construction industry and it also brings to sand mining activities. Because of that, it can also cause the destroy of ecosystem life because of that sand mining activities. And lastly, to study the potential of the Kenaf core as a partial sand replacement. The objective of my research is to investigate the effect of the Kenaf core as a partial sand replacement in terms of strength and to determine the effect of the Kenaf core as a partial sand replacement in terms of water absorption in brick. So, let me move to the project scope. So, the Kenaf core that I used for this research, I obtained from the Lembaga Kenaf and Tembakau Negara and the replacement used is 0, 5, 10, 15, 20 and 25% of the Kenaf core and the replacement used is by volume. And there are three tests are involved for this research. First is compressive strength test, flexural strength test and lastly water absorption test. The size for the specimen is 225 times 113 times 75 millimeters and the total sample is 72 and the design is 8 Newton per millimeter squared. Next, the significance of study for my research is to find out the potential of the Kenaf core as a partial sand replacement. Next, to minimize the use of sand in construction industry. And lastly, helps to reduce environmental pollution from sand mining activities. So let we move to the literature review part. From the Ishaq et al., the research is about to compare the mechanical properties of short Kenaf bars and core fiber reinforced unsaturated polyester composite with varying fiber weight fraction 0, 5, 10, 20, 30 and 40%. And the output is Kenaf has good mechanical properties and can grow quickly, rising to as high 4 until 5 meters within 4 until 5 months with growing season, the Kenaf stock diameter of 25 until 35 millimeters. And the highest tensile strength for both bars and core fiber composite was at 20%. And from the author tooling IH and PODCL, the research is about to investigate the compressive strength and durability properties lightweight concrete bricks under full water curing and air dry curing. And the output is water curing has higher compressive strength for 3, 7 and 28 days than air dry curing. And from Ashraf et al., the research is about determining possible sand deposition and their flow towards Selangor River. And the output is sand minings involve removing sand can also have environmental problems from their natural configuration. And it occurs when the sand, gravel and other material attraction rates surpass the rates at which these materials are produced by natural processes. For methodology part, there have 4 processes are involved. First is material preparations, mixed proportion, sample preparation, and lastly, testing consideration. For material preparation, we need to prepare cement, water, sand, Kenaf core, and sodium hydroxide. Sodium hydroxide used as a treatment process, and Kenaf core needs to soak into the sodium hydroxide for 24 hours before start casting. And sample preparation involved is mixing, casting, and curing. For curing, we have a different age, which is 7 days, 28 days, and 56 days. And testing consideration involved is compressive strength test, flexural strength test, and lastly water absorption test. And after that, we can get the result and do analysis from the result. So let we move to the result and discussion part, which is include compressive strength test, pressure strength test, and water absorption test. The result for the compressive strength test at 7 days shows the specimen contain 5% of the Kenaf core has the higher compressive strength test compared to the control specimen. And for the specimen contain 20 and 25% of the Kenaf core cannot be testing on 7 days because it's not fully dry and we cannot remove the brick from the mold. The compressive strength test at 28 days also shows the specimen contain 5% of the Kenaf core has the highest compressive strength test compared to the control specimen. And for other specimen like 15, 20, and 25% of the Kenaf core, we cannot test on the that day because of the MCO. And the result for the compressive strength test at 147 days also shows the specimen contain 5% of the Kenaf core has the highest compressive strength test compared to the control specimen. Supposedly, all these specimens we need to test on the 15th days, but due to the MCO, we cannot manage to do the testing on that day. And from the result of the compressive strength test, we can conclude that the increase of the Kenaf core replacement will decrease the strength of the compressive. Let we move to the flexural strength test result. For the flexural strength test, we should test all the specimens on 28 days, but due to the MCO, we manage test several specimens on the 28 days and other specimens on 147 days. And from the result, we can conclude that the specimen contain 5% of the Kenaf core has the higher flexural strength test compared to the control specimen. And we can conclude that the increase of the Kenaf core replacement will decrease the flexural strength of the specimen. And we also can conclude that the increase of the Kenaf core replacement will decrease the flexural strength of the specimen. For the result from both tests, which is compressive strength test and flexural strength test, the strength decreased because of the effect from the water content. It is because the Kenaf core that I use, I cannot dry before start casting. And because of that, it will affect the water content of the specimen. So let we move to the water absorption test. For water absorption, it's same with the flexural strength test, and I test on the 28 and 147 days. And from the result, we can see that the increase of the Kenaf core replacement will decrease in terms of the water absorption. The conclusion for this research is, in terms of compressive and flexural strength, the brick contain 5% of the Kenaf core as a partial sand replacement achieve high strength compared to the control specimen. And in terms of water absorption, the increase of the Kenaf core replace will decrease the percent of the water absorption. And there are several recommendations needs to do to increase the strength of the cement brick. The first thing needs to do is we need to do adjustment of the water cement ratio to get a better strength of the cement brick. And before start casting, make sure the Kenaf core should be dry from the treatment water. It may affect the water content during the casting if we not dry the Kenaf core first. These are some of the references that I use for this research. That's all from me. Thank you.